All right, class, this is Algebra 1, Lesson 10.1, Factoring Out Common Factors. And as is often the case when you start a chapter, the first lesson is really an important lesson. And so here it is on video. You can come back to it and watch it a few times. Maybe halfway through the chapter, you're struggling a little bit with this key concept. Come back and take a look at the lesson. It is foundational to everything we're going to do, not only this chapter, but pretty much the rest of your algebra career. So last chapter we looked at multiplying polynomials and we multiplied binomials and trinomials and such like that. Now we have to learn the reverse process, and that's the aspect of factoring. So factoring. And factoring all starts, factoring of polynomials starts with this aspect of factoring out common factors. Factoring out common factors. That's what we need to talk about today. This is an important concept. Make sure you focus upon it. Bring questions with you tomorrow in class that are concerns, and hopefully we'll get everything figured out so that you are ready to go and you have a full understanding. All right, so number one, factoring out common factors is using the distributive property. Using the distributive property in reverse. Using the distributive property in reverse. So if you look at A here, I've got an example of the beginning of the distributive property. A times the quantity B plus C. And if you remember, we're going to multiply this A times the B. So I'm going to use my color here, my red A and my black B. And then I'm going to take my A and I'm also going to multiply it times the C. Whoops, keep getting my other colors there. Let's get rid of that. Plus, and then my red A times my black C, right? Distributive property. We've done that numbers of times, course reviewed that just last chapter again. So A times the quantity B plus C, you multiply the A times the B plus the A times the C. Well, what do we do in factoring? In factoring, we're going to take the property and we're going to do it in reverse. We're going to unmultiply. You see that common A? The A is common to the B and the A is common to the C. The A is common to both factors. So we're going to take that A out. We're going to put it out front and then we're going to put a parentheses for what's left. So if you pull the A out, what's left? The B plus the C. And you can now see that we have done the distributive property in reverse. So if you look up here at the distributive property, this would be first, this side, and this side would be second. In factoring, the second side is first, and the first is second. We've really applied the symmetric property, and we flipped sides. Well, that's factoring. Factoring is the distributive property in reverse. And so that's the concept. Now, what are we really doing? We're really, you can write this, we're really unmultiplying. Right? That's what we're doing. We're unmultiplying. All right, well, what's unmultiplying? Well, in reality, then, that means we are dividing. That's what we're really doing. Okay? I don't want you to write this, but I just want you to seek to understand what is really going on with the distributive property. So don't write this. This is really the math of everything. Okay, so let's suppose I had that AB plus AC. Again, do not write this in your notes. You don't even have space for it, right? Okay, if I want to factor out this common A, really what I want to do is I want to multiply it by a form of 1. So because I see I can get a common A out, I want to multiply this by A, but not just A because that's not 1. I want to multiply it by A over A. That is 1, right? A over A is 1. In addition, I'll then write A times 1 over A equals AB plus AC. Now, before I lose you, isn't an A times a 1 over A the exact same thing as an A over A? I hope you would agree. So again, this is really what's going on. If you don't understand this part, don't worry about it. It's okay. I'm just trying to get the few that really understand what's going on. So watch what happens with the division here. What I'm going to do now is I'm going to divide both of these by that A. You can look at that as division, or you can look at it as distributing the 1 over A to both. In either case, that's where you're going to end up. So you see that division part? Now what ends up happening? A divided by A is 1. A divided by A is 1. And where do we end up? A times the quantity B plus C. Okay, so that's actually what's going on. We put the factor out in front and we divide by the factor. Let me show you that same concept here with numbers. Again, don't write this. I'm just trying to get you to think here in the beginning so that you'll understand the mechanics of what's going on. Actual factoring is easier, okay? So again, just hang in there. If everything's not quite clear to you, that's okay, because I'm going to show you in a minute what's really going on. So if I had a 2x plus 6, now see, I clearly see the 2 there and the 2 that's here, right? There's a common 2 in the front 2x and in the 6. In case you don't see it here, I'll clarify for you. A 6 is a 2 times 3. So now do you see that common 2? And surely you do. So technically, to factor, to put a parentheses around it, we'll take that common 2 and put it out front, but because we have to do this in the form of 1, we'll also divide each term by that 2. Dividing by that 2, what's 2 divided by 2? That's 1. What's 2 divided by 2? That's 1. And where do we end up with? We end up with 2 times the quantity, x plus 3. 2 times the quantity, x plus 3. Now, by the way, this will be our next note, and it's there already in your notes. I can always check by multiplying everything back out using the distributive property. What do I get? 2x plus 6. I better get back to my original. And in fact, I did. Okay? That's the idea. That's the concept. And this is what's going on with factoring. Okay? All right, let me get rid of this here. All right, so that brings us then to B there, and I just mentioned that to you. So let me just show you where I'm at here. Check your answers by using the distributive property to see if you get the original. So look, when factoring out common factors, you can always know if you're doing things correctly by taking a moment at the end and using the distributive property to multiply it back out and see if indeed you get back to the original. So there's really no reason to miss any of these. There isn't. All right, so number 2, how to factor. How to factor. Look for factors that are common to every term and factor them out as a multiplier. Factor them out as a multiplier of what is left. Again, look up here. You don't need to put this in your notes, but isn't that what I found here? A common A to both terms. And what did I do? I factored it out as a multiplier of what is left. Do you follow? That's factoring. It's not hard. And if you get an understanding, you'll be in great shape. Now, let me pause for a moment. There are situations in courses where an author of a textbook will decide to present material in a certain way. All right, there are a lot of different ways to skin the cat. So if you look in your book, you're going to look at talking about the GCD or the GCF and looking for the greatest common factor of all the terms and factoring those out. Though all that is correct, you're going to get caught up in that. And so though you can factor exactly the way your textbook's going to lay it out, if instead you'll develop the intuitive view that I'm trying to give you now, you'll be able to quickly and accurately factor everything. So I say all that to say this. I'm trying to teach you a method um, that will allow you to be successful in your factoring. If you instead say, well, I didn't quite understand what Mr. Scarfi said, let me look at the book, you're going to see a conflicting view. So just be careful there. I don't want you to get confused, and that's the only reason I'm mentioning something right now. So be careful, be careful, be careful. All right, let me get my shade going here so that um, we don't have all these problems showing. All right. Okay. So let's take a look at A and B. All right. First off, A. Now I used color to try to help you out and try to help you to see clearly the common factors. So if you look at A, what do you think uh, are the common factors? And hopefully you say, hey, I see a common 5. All right. Great. Just pull that 5 right on out and stick it in the front. Put a parentheses for your multiplier because it has to be a multiplier, right? That 5 is a multiplier. And then look, what's left? What do you see inside? An X. Keep this sign here plus a Y. And again, if we did everything correctly, you should be able to multiply this back out. So what would be your check? 5 times X is 5X. 5 times a positive Y is a positive 5Y. 5X plus 5Y. Okay, I'm good. That's the correct answer. I'm good to go. I checked. Okay. Now B is a little unique, and I've chosen this example to help you to understand what happens when all of a factor gets factored out. So most students don't have a problem in seeing the common 7, and they'll take that common 7 out. They will then say this to themselves, what's left is an n. Now, don't write the rest of this in your notes, but this is what they'll give me, 7 times n. And they are correct, they factored out the common 7. But look what happens when you do the check. Again, don't write this in your notes. You get a 7n. Is that the original? And the answer is no. So what went wrong? What's the problem? Well, they missed this aspect. When you take everything out, indeed what's left is a 1. You can think of it this way. Isn't a negative 7 the same as a negative 7 times 1? So really, what do you have left? The negative sign and the 1. Now look what happens when I do my check. 7 times n, 7n, 7 times negative 1, negative 7. Ah, there's the original. So I've got to tell you, be careful. I see this all the time. When you're able to factor out every factor, boy, that's not the creative pin I wanted. Let's get rid of that thing. It's going for stars here. Um, when you factor out everything, make sure that you leave a 1 in its place. When all of the factors get factored out, make sure you leave a 1 in its place. And again, that's what's going to allow you to get back to your original. So be careful in that situation. It comes up and you need to be careful. All right, let's see. Can't get to my extend the page, so we're going to do it this way. All right, let's take a look at our next two examples, C and D here. All right, so C, I'm still using color for you. At any time, if you want to do the problems yourself at this point, just go ahead and pause the video and go ahead and work them and then turn it back on and see if you're correct, all right? Okay, so if you look at C, you're looking for what's common to all three terms. We have a trinomial now. So it's got to be common to all three. Well, if you look, I see a common 3. See a common 3. All right, and again, a 6, just to help you see it, you don't always need to do this, is a 2 times 3. And then 18 is a negative 6 times 3. And do you see that common 3? Hope you do. So what's left? A 2a squared is the front. A positive a is in the middle. And what's left in the back? A negative 6. Now again, if you multiply back out that 3, you should get back to that original. 3 times 2a squared is a 6a squared. 3 times a positive a is a positive 3a. And 3 times negative 6 is a negative 18. And there you are. There you are. Okay. Here's another common situation that you've got to be careful with, and that is when the common variable is there. So you can get out a common x, can you not? All right, we're not dealing with numbers now, we're dealing with a variable. Look, what is an x squared? An x squared is an x times x, is it not? Do you see the common x now that we can factor out? So I'm going to take that common x out. Now I've just taken the common x out, right? If you want to, you can cross them off when you take them out. What's left in the front? 11x. Oops, wanted that to be black. What's left in the front? 11x. What's left in the back? Negative 5. Again, multiply back out to check. But x times 11x is 11x squared. X times a negative 5 is a negative 5x. And sure enough, that is the factoring of that. So you can get variables out as well. If you look at example E, right? What's common to all three terms? Are there any common numbers? Got 5, 3, and a negative 17? No. 5, 3, and 17, nothing common with numbers. How about the variables? Got a y cubed, y squared, and a y. Oh, yeah. Yeah, I can get a common y out of that, right? And what's left when I get one of the three y's out? A y squared, right? A y times y. I had a y squared, a y times y. I took one out. I have just a y, and I have a negative 17y. When I take out that y, it's just negative 17. Again, I can check by using the distributive property because we've just used it in reverse, and I can just multiply everything back out to see if indeed I am correct. And in fact, I am. All right, so F, I've got red and green involved. You know why? Because you can factor out a common number, and you can also factor out a common variable. All right, so why don't you go ahead and do that? Factor out the common number and factor out the common variable. See what you can do with that. Again, pause the video and then start it up as soon as you're ready to go. All right, so you take a look and hopefully you factored out the common 2 of the numbers, and then hopefully you're, well, let me do it this way. When you get out that common 2, let's just do our number part. What's left with our numbers? A 5 in the front, right? And a common 2 would leave you a negative 3 for the number in the back, right? Let's go on to our variables. What else do we have common in variables? We have an a. I can get an a out of both the front and back terms. That leaves an a in the front, no more a's in the back. And whatever else is left is left. There's still a b left in the front and a c left in the back. Did you get 2a times the quantity 5a minus, 5ab minus 3c? All right, hope you did. What are we doing? We're taking out the common factors. It's got to be common to every term. In this case, again, don't write this, I'm just getting you think. This is binomial, had to be common to both of the two terms. Here we had a trinomial, had to be common to all three terms. If it had 4 terms, it'd have to be common to all 4. 5, common to all 5, etc., etc. So what are we talking about in factoring? We're talking about using the distributive property in reverse. So what are you in effect really doing? What are you actually doing? You're looking for factors that are common to every term. So that's what I just got done saying, right? If it's a binomial, it's got to be in both terms. Trinomial in all 3. Polynomial at 4 terms has to be common in all 4. And factor them out as a multiplier of what is left. When you pull them out, what's left? Remember, you're pulling that common factor out. All right, so let's take a look at this one. Again, pause the video if you want to do G on your own. No more color, so you're going to have to look, and you're factoring the common factor. Okay, so look, I'm good at this. I should be. I've taught this now for 29 years, and so it's old nature to me. Very, very simple. I see it very, very clearly. But just to help you out, do you see the common 3 in the front 3 terms? If not, let me do this. Let me get my red here instead of my purple. All right, a 15 is a 3 times 5. And a 9 is a 3 times 3. All right, let me cross out what I used. And a 12 is a 4 times 3, right? you see those common threes? 3, 3, 3. Okay, let's get that common 3 out. And I'm just going to leave some space. Now, what's left? I took that 3 out. I got a 5 left. I took that 3 out. I got a positive 3 left. I took that 3 out. I got a negative 4 left of the numbers, right? Okay, let's look at our x's. I got 1x. I have x squared. That's an x times x, right? Again, I'm just showing you the breakdown. I normally wouldn't do this because it's clear in my mind, but in yours it may not. Okay, so let me take out that common x. Okay, I just took it out, so it's gone, 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 right? What's left with our x's? No x's in the front term, an x in the middle, no x's in the back. And look, lo and behold, we got a y we can get out as well. A y cubed is a y times y squared, right? A y squared is a y times y, and so I'll get a y out of the front, y out of the middle, and a y out of the back. All right, there I took it out front, so I get rid of them. What's left? I still have a y squared in the front. I've got a y in the middle, no y's in the back. Close that with the parentheses. 3xy times the quantity 5x squared plus 3xy minus 4. Isn't that cool? Now again, would I normally do all of that writing of the factors? No. No, but that's what's going on as you're looking for these common factors. So if you can't see them clearly in your mind's eye, then write them out. Write them out. So let me do H without writing all that. And again, if you want to do it yourself, go ahead and pause the video. All right, so when I'm looking for common factors, I always look at the numbers first. And I'm looking at negative 20, positive 10, a 30, and an 8. So I got a 20, a 10, a 30, and an 8. 10s were looking good for a while, but there's no 10 in that back term. So there's a 4 in the front term, but not a 4 in the middle. So the only thing common I see is a 2. Now, one thing you got to be careful about is you got to get all the numbers out that you can. All right, so let me just do the numbers. When I get a 2 out of the front, I have a negative 10 left, right? So it's a negative 20. A 2 times a negative 10 is a negative 20. When I get a 10 out of the middle, or the second term, I have a positive 5 left. 2 times 5 is 10. When I get a 2 out of a negative 30, I got a negative 15 left. Again, you could just divide the numbers if you want. If that's the way your brain thinks. But again, I'm thinking of pulling that 2 out, leaving me a negative 15 left. And again, an 8 is a 2 times 4. So when I pull that 2 out, there's a 4 left. Okay, that's my mind. Now look at my y's, and though I can get a y out of the front, a y out of the middle, oh, and by the way, I changed that, it's supposed to be a squared, y out of the second term, y out of the third term, I have no y at all in the fourth term. And remember, it must be common to all terms, so therefore I can't do anything with my y's. They all stay in. Y cubed, y squared, y, and that's it. 2 times the quantity, negative 10y cubed plus 5y squared minus 15y plus 4 as we work our way through the aspects of factoring. All right, a couple more. How about I? How about I? So again, pause the video if you need to. My mind's eye. I see a common 2, but I see more than that. I see a common 4, but I see more than that. I see a common 8, right? There's a common 8. Be careful. Here, let me use my red here. What number is left? 16 again is a 2 times 8, right? This is what I'm doing in my mind's eye. So I have took the 8 out, the 2 is left. A negative 24 is a negative 3 times 8, right? So again, I pull the 8 out, and what's left? The negative 3. I'm going to start working my variables. I look at my n cubed and my n squared. I'm pulling out an n squared. What does that leave of my n's? 1n, right? Pulled them all out of the back. Let me look at my y's. I have 3 of them here, but only 1 there, so I can get 1 out. Leaves 2 there. none in the back. Be careful. Don't forget that Z that is still there hanging in the back. All right, you got to be careful. And again, you can always, and you should always, multiply it back out and make sure you get where you're supposed to be. What's my check? 8 times 2 is 16. N squared times n is n cubed. Y times y squared is y cubed. Check on the first term. Back term, 8 times negative 3, negative 24. N squared, I have that. Y, I have that. Times z, I have that. Check. That is the correct factorization. Hey, all right, little interruption there of a staff person came by. Okay, so let's go ahead and look at this last one. Again, I'm looking for what's common. All right, I look at my numbers and I only see a common 2. That's all I see. That leaves me a 4 in the front, a plus 5 in the middle, and a plus 10 in the back. And you can see out of those numbers, there's nothing common in a 4, a 5, and a 10. Start looking at my variables. A cubed, a cubed, a squared. The most all of them have is an a squared. Leaves me an a in the front, an a in the middle. All right, let me go to my next variable. B cubed, b squared, b squared. Okay, I can only get out a b squared. Leaves me a b in the front. All of the b's are gone out of the middle and the back. Last, look at my c. C squared, c squared, c cubed. Okay, I can get a c squared out. All the c's came out of the front. All the c's came out of the middle. I'm left with one c in the back. There's the factorization. 2a squared b squared c squared times quantity 4ab plus 5a plus 10c. Again, multiply back out. Do you get the original? Multiply back out. Do you get the original? If you do, you factored it correctly. And you definitely want to factor things correctly. All right, let me finish off. And so take a look at number 3. Not every polynomial can be factored. So let me just pause real quickly. Can every number be factored? You know, a 6 is a composite number, right? A 2 times 3. A 10 is a composite number, 2 times 5. But a 7 is not composite, is it? And can a 7 be factored? No. Can a 3 be factored? No. Can a 2 be factored? No. Can 11 be factored? No. Can a 13 be factored? No. 19? No, etc., etc. And when a number cannot be factored, it's not composite, it is, and hopefully your mind is saying prime. It's a prime number. So same way with polynomials. So look at the polynomial here. Anything common between a 12 and a 7? No. Anything common on the second term with the variables with the x and the y? The answer is no, so this is prime, right? It's a prime number. Our second example is a trinomial. Again, I'm looking at my numbers. Anything common with a 15, 3, and a 1? The answer is no. All right, how about common with my variables? X squared x, yes, but no x's in the back. So no, there's no common numbers, common all 3 terms. No common variables, common all 3 terms. This is also prime. Factoring out common factors. Foundational lesson, not only to chapter 10, but to pretty much the rest of your algebra career. And we're going to do some more factoring all this chapter, and this is the foundation to factoring and the foundation to a lot of things down the road. So it's really important that you understand. If you're struggling with that understanding, please bring questions with you tomorrow in class, and I'll be glad to try to take some more time and we'll work some things with you and try to help you to understand. All right, homework is not due yet. We will do that in class tomorrow. All right, so homework not due yet. It'll be due in class next time class meets. All right, have a great night.